and to get to the center of a Tootsie Pop. How could I find out? Like, say, I do not know the mean number of licks. I don't know what it is. This is starting chapter 7. It's true. I don't know what it is. Can you stop? Thanks. I don't know what it is. Sydney, how would I get a clue about this? Here's a hint. It's statistics, so I should take a... There you go. Yeah, I should take a sample. Take a picture. Who said that? Smack yourself.
Sorry.
I should take a sample. That's right. So I'm going to choose a sample size. I'm going to take 100 sample this time. Here's a Tootsie Pop. Start licking. The whole bit. I get all the data in. Shh. 195 is what it come out to be. I don't know. I just work here. That's what I was told when I reached around and pulled it out of the Magic Pez dispenser. Now, Mr. Graham, I feel like we should have a standard deviation. We do. Notice that it is not sigma. Very seldom would it ever be sigma. For crying out, I don't know nothing about the mean. How do you think I'm going to know anything about standard deviation? I'm not going to know anything about standard deviation. So, as a general rule, I'll be finding the standard deviation of the sample. And so it is 10.7 licks. Sure. From the usual orifice, yes, indeed. Now, here's the deal. I feel like, Emily, I could draw this little picture. You've seen me draw it about 1,000,000 times, haven't I? And I feel like I could put 95% in the middle. Notice how that's different than what we did before, yes? For the most part, before we were saying we went to lower 10 or the upper 15 or the whatever, yes? But this time I want the middle 95%. Can I find this z-score right here? And first of all, that's a negative and this is a positive, the same value, yes? Now, how could I find this one down here? How would I do that? By the way, not new, this part. How do I find it?
The z-score?
Yeah.
You do 195 minus 100 over 10%.
No, not at all. I do inverse normal, yes? Of what? No. Inverse normal of 0.025. Now, how come I know that? Because it's the amount that's less than. Well, how do I know it's that, Mr. Well, you got 5% on the outsides, half of it's on the bottom end, yes? You should check that you can pull that off on your calculator / computing device to remember that you're good. Anyway, it turns out it's negative 1.96 and positive 1.96, yes? Am I right? I feel like I am. Anyway. Now, as you well know, to make a z-score, a fella or lady or whoever does this. Right? And notice how I swapped out the sigma for Sx, right? Okay. Now watch carefully. Are you watching? This is where the trick comes today. Are you watching? Are you watching? This is exciting. Watch me. Wait for it. Watch me do that. Now what have we just done, friends? Feels like we've put a negative z-score and a positive z-score there, yes? And it seems to me that we know what these two z-scores are, yes? Feels like we know this fella, and we know this mess on the bottom. But we've made you take Algebra 2 for a reason. It's right here. Watch carefully. Watch me multiply both sides by that denominator. Now, we will never do it like this ever again, so this part that I'm showing you is simply where it comes from. Some people always get, Mr. Groom, I feel like... nobody cares what you feel like. It's fine. Okay, this is where it comes from. We'll get down to the end in a minute. You'll be like, oh my gosh, that's so cool. I know. How do I solve for mu? I feel like I'm going to subtract x bar to both sides, yes? Watch me do it. If you're not following along with this, just wait till we get to the end. And then you're like, oh my gosh, that's totally easy. I know. Why are you writing in that order? I have a reason. Just go with me. Just go with me. Okay. Ooh, it's negative mu. I don't want negative mu. What the heck, yo? Watch me times everybody by -1. What happens when you times by negative when you have these little, these less than or equal to signs? What happens to them? They flip. So these side over here will both be positive, yes? They'll be greater than or equal to, right? So watch me flip the ends of this thing over. It's going to end up being this guy right here. Anyway, suffice it to say, this thing right here is where it's all about. That's the bottom line. I prefer to write it thusly, however. Okay? Because what is the difference between the two sides? Either you're adding an amount or you're subtracting it, yes? That's the only difference. So me personally, being the lazy person that I am, I'm always going to compute this piece here first, and then I will add it onto x bar, and I'll subtract it from x bar, and I'll be done. Piece of cake. We call this part the margin of error. And what we just found is a confidence interval. Chapter 7 is all about confidence intervals. Mr. Groom doesn't know anything about the number of Tootsie Pop licks it takes. I want to know. I take a sample. And I create a confidence interval. And then I say, look, I don't know what it is, but I'm 95% sure it's between here and here. That's it. Or I could say it's this. By God, it's this. With a margin of error of plus or minus 5 licks or whatever it is. Oh, okay. I'm not going to say it any other way I want to. Now let's try it with the one we have. See? Now again, I would do, hey, how many licks was it? 195, is that right? Plus or minus 1.96. What was the standard deviation? 10 point something? Over the square root of 100. Nice. So again, Mr. Groom is lazy. So I'm going to compute this margin of error business first. So it turns out that this is something like 1.07 times 1.96 is roughly 2-ish. It's 2-ish. Go ahead and punch it out, but it's 2-ish.
Okay, quick
What?
question. At the end, okay, so since you did like the shortened way of the plus minus, at the end, will you just make the answer negative? Or?
Oh, you'll see. You'll see. You'll watch. Just go with me. Just go with me now. All right, 2.09. Are you with me? 2.09. Meaning that I could have as many as 197.09 or as low as what? I don't know, whatever that subtracted is, 192.91. Right? Ta-da! That's it.
191.
I don't think so.
Oh, I see 192.
If it was 2, it'd be 193, so. There you go. Ta-da! Now again, I don't know how many licks it takes to get to the bottom of a Tootsie Pop. But I am 95% confident that the true mean is in that interval. Okay? Technically, this interval captures the true mean 95% of the time is how we should say it. But I'm okay with you saying I'm 95% confident the true mean lies into that region. Okay? Anyway, I'm pretty confident that it's right around there. That's what we're saying. Yes, what, dear? Anna? Anna, what? So 195 plus 2.019 and 195 minus it. That's it. Piece of cake. We could literally do this until we're blue in the face. We're going to stop short of that today, Victoria, but we're going to do many more. What?
Is it always going to give you the X bar and all that good stuff?
Here's the dealio. As always, watch carefully. you might want to pay attention to this. It's kind of a big deal. I don't know something, so I take a sample. As soon as I take a sample, they have to tell me, the book does, or I personally do, how big a sample did I take? But the results from that sample, which will be a what? A mean and a standard deviation. So yes, you'll always be given those. Yeah. And how confident do you want to be? 95%? 90%? 99%? Now, the big three are 90, 95, and 99. Those are the big three, but that's just weirdness. You could do a 50% confidence interval, but why would you? That's just weird. Now, here's the deal. We would like to be as confident as possible, yes? So, watch this. Josie, you may not know this, is very good at shooting. So she takes her G word, and she says, I will bet you $100 that I could hit the gymnasium. And you went, okay. From where? From inside it. That's good shooting, Tex. Yeah. I'm in the gym. I'm pretty confident that I can hit the gym from shooting inside of it. You're like, Caleb goes, well, now, Mr. Groom, I have built a dart gun with a blow gun. One of them jobs. I'm 90% confident that I could hit a bale of hay at 50 yards. Well, now that's saying something. That feels like that's saying something. You know, at some point you're like, Jacob, you know, he's into that long range shooting stuff. 1,000 yards, I could hit the target 50% of the time. Well, it's pretty good, I guess, but it just feels weird. Why don't you move it in to where you're like, I can hit it 100%, like 99% of the time at 400 yards. Hey, that's pretty good shooting right there. Oh, okay. So there's that cross between I want high percentage, but I don't want such a big target that my high percentage doesn't mean anything, okay? I would like to have a small-ish target that's something to be proud of hitting. I'd like to be able to hit it a high percentage of the time, okay? So I can hit it 20% of the time. Woo! That's nothing to brag about. Shut up, okay? So baseline is typically 90%. That's usually for the cases that you're dealing with sociology and your psychologies and your touchy-feely soft sciences. Because as you know, people are weird. Hey, let's have so the average person, let's rate your pain on a scale of 1 to 10 when you break your arm. Oh, look, here's a kid. He's crying his eyes out. How does it make you feel? It's a 10. Where? And then you get some gal comes in there and she's just gritting her teeth. How's it feel? Oh, it's about a 3. That's fine. And you're like, it clearly hurts a lot. Are you sure? I said it's a 3. You're getting no bonus points for being tough here, lady. It's a 3. Just give me some painkillers. It's fine. And so obviously there's a lot of flippity-floppity there. It's just not a deal where you're weighing armadillos or something that's nothing strange. In that situation, 95 is the classic when I say more of a hard science sort of a deal. Testing fertilizer response, that sort of thing. Okay? Now, let's do another. Mr. Groom wants to know. I don't know. I can't think of anything. Josie comes something weird. Yes, Josie wants to know the average weight of, yes, armadillos. So she finds 50 of them. Good for you. And she finds that their average weight is, I don't know, what do those suckers weigh? 5 pounds, I guess? I don't know.
One rolled out in front of me and it was fat.
Whatever, 20 pound. A standard deviation of.
That's too big.
Apparently I need to calibrate the orifice, apparently. I don't know. Now, let's just go with the 90% confidence interval this time, just for grins. So, whoop. Again, we want the 90% to be in the middle.
62 to 71.
What?
That's the weight, average weight of
What are they?
62 to 71.
Holy moly. I told you they're huge.
Nobody cares. Nobody cares. It's all right. Here we go. Here we go. Here we go.
That's a big one.
So 0.05. 0.05 is down here. That's negative 1.645-ish. Positive 1.645-ish. Because back in the day, before we had these little fancy calculator crap, you memorized all this junk. And then I've been doing this for a long time. I don't know how many rap songs do you have memorized. I don't know. Point is, you memorize crap that you deal with all the time. Even some stuff that you'd like to forget, you get stuck in your head. So I'm sorry. Here we go. Now, again, let's set this thing up. So it's 20 plus or minus z times the standard deviation over the square root of 50. Oops, and I write 40. Attaboy. So again, if you're smart, I think you'll compute the margin of error first. I'm just watching. Just trying to make you feel uncomfortable. Am I doing a good job?
Eh. Depends on there. What's the name?
0.95-ish.
0.95.
Hey, stop. Is that what you get? So 19.05 on the lower end. And on the upper end, 20.95. Muy bueno. It is not very difficult, friends. All right. Now, Abby wants to know the average length of teenage girl hair. By the way, can I just say that you might think that sounds goofy. I'm not going to argue with you. That does sound goofy. Mr. Groom, for whatever reason, let's just suppose, how many teenage girls are there that she could sample from? A lot. Would it be very hard to get up a decent sample? No. In typical high school lazy butt fashion, though, what does she do? 10! If she gets a sample of 10, what could happen to that sample easily?
Get skewed.
Big time skewed. Big time skewed. Why is this thing vibrating? Why are you handing it to me? And
Okay, I
James
have a-
Thomas wants to know something.
No, that was.
Oh.
How do I square root stuff on that?
Oh, you use the squirt. So,
That's
you go equals, where is it at?
right here
Equals,
on top.
and then SQRT. I can't read that. SQ,
So if it was in the
SQRT,
middle of like an equation.
parentheses. Yeah. Shh. All right, back to this. Now, again, you want to take a decent sample size. Now, there will be times when, Abby, you will want to take a small sample size. Yes? For instance, there's only so many Siberian tigers in the world. Shh. There's a lot of them, but not a lot. But there's not that many. But the point is, there's enough that you can get a decent sample, like 6 or 8 or 10, but not like 50 or 100 of them. By the way, they're hard to find, yes. If you had to take, like, say, I think the reason they're not reproducing is because I think a lot of the males have a low sperm count, so I had to collect a sperm count and test it. How hard would that be? It's a little dangerous, a little expensive. Now, Mr. Groom, why do you say it like that? Because listen, if all you have to do is spot them and count them, that's not very difficult. I mean, it's tricky, of course, to find them, but it's not dangerous. So I say let's up the ante. Let's go dangerous, difficult, and expensive. So sometimes you're going to have small sample sizes. The case of teenage girls, there's a lot of them. Just get me a decent sized sample. So today, we're going to sample, I don't know, 70 girls. And the average length of hair is 20 inches. I don't know. And a standard deviation of 6.2 inches. That seems gross and really long, and I don't know, 3 foot long if you're 2 deviations, but who cares? I'm going with it. Let's roll. Again, it's just numbers. And I'd like to have a 92%. I thought you said the other. Listen, does it really matter what this is? So what I do is I draw the little picture. If you're not drawing the picture, you're asking for trouble, I think, personally. I think if you draw it, it's really hard to screw it up. But it's easy to screw it up if you don't draw the picture. Do it however you want to. That's 8% on the outside, which is 4% down here. Right? I feel good. So what is that? Inverse normal, what's my z-score?
1.75.
So 1.75 plus and minus. That's correct. I'll buy that. So x bar plus or minus 1.75, 6.2 over the square root of 70. Just one question. What does that mean when it said 1.75? What that really means is this. It means plus or minus 1.75 deviations. You see that? That's what that really means. This is a deviation. This is 1.75 of. Yes, dear.
Okay, where'd you get to 1.7?
Yeah.
Inverse normal, 0.04. Try it now. Try it. I took the words right out my mouth. I love it.
Thanks.
This is muy fácil, yes. Yeah. Muy. Somewhere in there. I don't know where it's at. I don't really care. Yes? All I remember that is the Spanish teacher used to yell at me all the time. What's up? Hey, what'd you get?
1.29.
1.29? So somewhere between 21.29 on the top end and
18.71.
18.71 on the bottom end. Beautiful.
Together. Seriously, we need to stop. Or just stop sharing.
Mr. Kroom, all we're dealing with here is z-scores. So when you say it makes more sense than the last one, this is z-scores. That's all this stuff is. We just turned it inside out and solved for something else. Oh dear. Not very hard. Now, Megan, I have a question. God dang it. Hannah, it was on the tip of my tongue, and then for some reason, listen. Hannah would like to do that same study that Abby just did a minute ago, but she would like to have a margin of error. This is important. Less than 3/4 of an inch. See, Abby just had a margin of error of 1.9 inches or 1.29 or something inches, yes? How could Hannah make the margin of error smaller? Well, what is the margin of error? It's this fella, right? Shh. I'm just going to call this E. That's what your book calls it, error. But here's my question, Hannah. If I want to stay with that 92% or whatever I said, I forget, at confidence level, then Z is not changing, right? And the standard deviation is pretty much going to be the standard deviation regardless. So the only thing I can really do is what? Make my sample bigger. Now, as you know, the bigger the sample, the less variation we have, yes? We drive it down. So, obviously N needs to be larger. So then the question is this. We know this is 0.75, yes? We know this was, what did we say, 1.75? And we know that this was 6. What was the? 6.2 over the square root of N. Now, how do you solve this for N?
Divide and then times.
What? No, what? Okay, here's the deal. I am going to show you the formula because, yes, we do make you do a little bit of Algebra 2 in this class. I believe your book actually uses sigma up here instead of SX. It's not a big deal. Just be aware that it could show up either way. Sigma SX, sigma's standard deviation population. the standard deviation, regardless. And so n would be equal to, now this is straight up equal to z sigma over e, the whole thing, squared. Now, that's where it's equal to. Could you get by with less sample size than that? Would you be okay with more? Yes. So n would need to be at least this big. Okay? Now you could solve this thing over here. It works the same way. But let's just actually punch it into this formula, shall we? So n would need to be at least z, so this, times 6.2 over 0.75 squared. And I don't know what that is, but... $144. $145. What? Well, it's a wild guess. But here, this is 9-ish. This is 9-ish. And 9 is 3/4 of 12. So it should punch it out to about 12-ish. 12 squared is 144-ish. But you say it's bigger than that. What is it?
106.7.
What? What? Oh, 106. I overshot. Whatever. That was a guess. I was just playing along. Notice it can't be equal to 106.7. It's really hard to take 106.7 girls' hair measurements, right? So we're going to say greater than or equal to 107, really. I know, that's what Alex got. If you disagree, let me know.
I got 209.28. 209.28.
Did you get
I've
209?
done it 3 times and I've got the same thing.
Bunch of freaking
Yeah, I got
losers.
209.
Did I do something else?
Did you put it like that?
I did that, and I divided it by 6.75, and then I'm not sure.
No, you put 1.25,
Oh,
not 1.75. It's all right. So what did you say it was? 20 what?
209.
So I undershot instead. So 210. Yes? 209 would not work because it was 209 point something. You need to go 210 or more. 210's a weird number. I've been around 225. Okay, good for you. Good for you.
That's more.
The higher you go, what will happen to our margin of error? Down she'll come. Okay, it's very straightforward. Yes?
is a decimal should be always round up.
In this situation, yes. In this situation, most definitely. No, in a case, no. Shh. This is important. In the case of sample size, you have to round.
Yes.
So then you have to ask yourself, would 209 work? No. Because if you had 209, you'd end up with a margin of error just a skosh bigger than 3/4. And I, by George, want it less than 3/4. So I'll round it up. Huh? Now, all right. Let's try this one. Blah, blah, blah. Listen, I want a 95% confidence interval, we say. And let's just say this was 100, 1,000, 1,200. Yeah, there it is. That's good enough. I don't care. I'm just going to shut up and write it. Oops. What are you doing? Try that. See what you get. That should be all you need. I don't know what it needs. If you need a story, make up a story. I mean, granted, it's more fun if there's a story to go with.
How do you find this little like social
So there's 95% of minutes, 5%.
Oh, so there's period? Okay.
Wait, so subtract 0.95 from 1. And divide by 2.
Because there's part of it's on the lower end and part of it's on the upper end.
We just give
So the
them
middle. That makes sense.
I was another question.
Did you get 1.95 for each side? So you got
Hi. Sure, I'll go on a date with you. No problem. Thanks for calling. Did you get my number, Dutch Brothers? Is that where you got my number?
no, it's not a person.
Oh, no, it was like a Marriott hotel. They thank you for calling. They're choosing us. And I was like, we understand. Wait.
Kind of matters a lot.
Where did you say that? Mr. Groom.
Yeah.
Point inverse of that.
Yes. Yeah. You got her? Where you going? How many square root? Ha! Ha! Yes. Hey, if you are in Google Sheets, shh. Hey, if you're in Google Sheets, Emily, shh. If you're in Google Sheets, a person might want to do this. 1.96 times 200, that's 2,000, divided by the square root of 50. The squirt. Nice. I mean, you already got a calculator out. There's no reason to have 16 calculators on your desk. You know, it's all right. It works. Was it 1.96? It was, yeah. So what do you got? So plus minus. Okay. What? 55? What?
1.5.
Oh. Get my hearing aid turned up, sorry. It's easier just to turn up the Alex. Turn your volume up a skosh. Alright. Is that right? Is that what you got? What? It's 55-ish. Nag off. Okay. All I can figure is some people might not round to 1.96. Some people might be like, I'm going to keep it exact. Well, good for you. Anyways, that's the game-ish. 55-ish, yes? And so 12.55 on the upper end, of course. On the lower end, 11.45-ish. Okay? Yes? Feels good? Feels good. Now, all right, now I'm going to show you a way to automate the process a little bit. Now, on the test, Mr. Groom, will there be a portion of the test where you do not let us use any sort of calculator device to or I actually have to show all my work? Yes. I mean, listen, you can still use a calculator. But I must show all of my work. Yeah, I'll probably have one question like that because I think it's important. I think this is a big deal. I think this formula is kind of a big deal. I think you really need to memorize it. I just think that's a huge piece. Okay, but take your TI calculator. If you have a TI 89, we'll start with you. Sigma or SX, it's just standard deviation, It's just over square root of n. Over the square root of n. Now, I'm going to show you this on the TI 89 first, and then we'll go 84, 83, whatever. So I'll go to apps, go to stats list editor, and in here you're going to go to F7. Do you see it? F7. So under F7, which is second there, I'm going to make what's called a Z interval. Mr. Groom, do I have stats or do I have data? You have stats, clown. We just told you all the statistics. So I click on this. It says, what is the standard deviation? What was it? 200? And what was X bar? I think it was 1200. And N was 50. No. 50. And the confidence level was 0.95. And it will spit this number out. 1145, 1255. Oh my gosh, who saw that coming? Notice also it says ME. Do you see it? What is ME?
Me.
Margin of error. Nice. Nice. Now, the TI 8384 is similar but different as always. So if you go to Stat Tests, and then down here ways, number 7, I think it is, says Z interval. Do you see it? And Mr. Green, once again, we have stats. And then type in your 200 and your 1200. And 50. And voila. Boom. I'm doing it, lady. That's how you type it in.
You don't touch the sea level thing?
Dude, it was already at 95, so I left it there. But if it was at 90, I'd switch it. Do not type in 90. Don't do that. It's 0.9.
Won't let me scroll the negative.
Then you screwed up. I can. OMG on. Dim bulb. I won't mention any name.
Well, it's funny because a bunch of the things that are on yours are like roughly the same line, like it's under the same things, you have to get there differently.
Okay, I'm done.
But with this one, I'm not exactly sure. Because I'm on the stats thing. And I clicked test, but there's no Z. I clicked that, and that comes up. That's why I'm
Type it in. All right.
asking him to help me after.
What about my Google Sheets? Shh. Google Sheets. Check this out. This is kind of a cool deal on Google Sheets. Ah.
There it is.
New Sheets. There we go. All right. Focus on this. This is big. So, equals confidence. Confidence. Well, maybe. Maybe. Your current Windows still. I don't care. Nobody cares what you think, you stupid computer. Oh, so you're just straight up not going to do it. Okay, well, screw you. All right, let's try that. Equals confidence. Parentheses. Now, again, it tells me what it's looking for. It wants to know alpha. Pay attention to this directions. Alpha is how much is on the outside. So if you want a 95% confidence interval, you will use 0.05. Not 0.025, 0.05. So 0.05. Okay? Now, what does it want to know? It wants to know the standard deviation. For which the last one was 200, yes? And then it wants the population size of the sample size, which was 50. Yes? Hit enter. Hit enter. 55, that's the margin of error, yes? So then a person would go 1200, equals 1200, minus that. And I suppose you put it there, equals 1200, plus that. And we're done. Again, it's just a matter of sort of speeding the process up. You should, really though, practice doing some of them the hard way. Okay. Go ahead and check yourself using that. I think it's cool. You should be able to use both. That's kind of nice. But I will make you do one on the test where you have to show all your work on the and no, you can't have notes, and no, I'm not going to put it on the board for you. You need to memorize that formula. Okay? That's it. Okay? Now, what, dear? Oh, for gosh sakes. If you have an instinct, I can help you too. No, it's the table. Is there literally
I didn't do anything. I'm innocent. Sure. I am. I'm a sweet little angel.
All right.
Even ask my parents.
Okay, so time we done 11:05-ish. Yes, 10:05-ish. I mean. All right. Now this is the first section of chapter 7. It would be really nice if, like, tomorrow when you walk in, you're like, I got that down, because tomorrow we're doing 7.2. Here's an idea. They're literally the same thing. Well, that's not true. I can't say literally. They're basically the same thing. The difference will be tomorrow we're going to use small sample sizes. The Siberian tiger bit. Well, I'm going to be less sure. That's going to be weird. I need a bigger window. That's right. So instead of using the Z distribution, we're going to learn a new distribution tomorrow. The T distribution. Does it look basically the same? Mm-hmm. Does it operate basically the same? Mm-hmm. It just end up giving me a wider window for my confidence bit. Okay? That's it. That's really all it boils down to. So because I say, it'd be really nice if you come tomorrow and have like some clue because you went home and practiced. That'd be really sweet.
No one actually did your homework.
Yeah, I know, right? And by the way, it's not to say that I'm not proud of people when they come to me and say, I did my homework. Are you proud of me? Well, yeah, I'm happy you did it.